Hey guys, welcome to Blockcast, the podcast that explores the latest developments and innovations in the blockchain space. I'm your host, Will. Today, we're going to talk about Axelar Network, a project that aims to deliver secure cross-chain communications for Web3. But before we dive into the details, let me ask you a question. Have you ever wondered how different blockchains can talk to each other? How you can swap tokens, access applications, or execute smart contracts across multiple chains with one click? Why is interoperability so important for the future of decentralized technology? If you're curious about these questions, then you're in the right place. Because in this episode, we're going to talk about how Axelar Network is solving the interoperability challenge by creating what they call a universal overlay network that connects all blockchain ecosystems, applications, assets, and users across the board. So yeah, Axelar is not just another bridge or a hub. It's a programmable interoperability layer that enables general message passing, pretty much transfer of any assets across any chains. Not only that, it supports logic to automate complex interchain tasks, such as connecting new chains or running dApps, and we're going to look at all of that today. Pretty exciting, right? Well, it gets even better because Axelar is built by a really competent team, experts in cryptography, distributed systems, blockchain technology. Some of them are founding members of Algorand, one of the most prominent projects in the space. And they have secured funding from pretty heavyweight players, reputable investors in the industry, the likes of Dragonfly Capital, Galaxy Digital, Coinbase Ventures, and a whole bunch of others. So, how does Axelar Network work? What are some of the use cases and benefits of using it? To answer these questions, we're going to divide this episode up into 4 segments. 1, we're going to explain the concept and architecture of Axelar Network and how it's different from other solutions. Previously, we've looked at push protocol, we've looked at layer 0, which work in pretty different ways. So Axelar is a little bit different, and we're going to look into that. Next, we're going to explore some of the features that Axelar has, such as general message passing, universal asset transfer, and we're also going to look at the Axelar virtual machine. And then we're going to look at some of the security and decentralization aspects of Axelar. So that's things like proof of stake consensus, quadratic voting, the validator security rules, and so on. Finally, we're going to look at the ecosystem, Axelar's token, and how useful it is to the network. All right, so stay tuned for an exciting journey into the world of cross-chain communication with Axelar. Don't forget to like and subscribe to Blockcast for more episodes like this one. Let's get started. All right, let's continue the first segment of our podcast, where we're going to explain the concept and architecture of Axelar's network and how it's different from other solutions. So, as I mentioned before, Axelar is a universal overlay network, and it connects a whole bunch of blockchain ecosystems, applications, assets, and users to deliver that Web3 interoperability. But what does that mean, and how does it work? Well, to understand that, we need to first understand the problem that Axelar is trying to solve. That is the lack of cross-chain communication, composability between different blockchains. So the thing is, blockchains are kind of like little islands. They have their own languages, protocol standards, features. Some are really good at some things and some not so great in others, and they all have their different strengths and weaknesses, right? But the big problem is that they're isolated from each other. They can't talk to each other or exchange data. That makes it a problem for developers and also users. That means that any dApp that you're using is essentially limited to one network. That means the liquidity that you have is also limited to one place. And you have to do all kinds of silly tricks like wrapping tokens, which isn't ideal, or even building bridges, which are difficult to make, number one, and also really difficult to secure. So, for example, if you want to swap tokens between Ethereum and Binance, you've got a bridge and you've got to do all of these kinds of things. The bridge sometimes can be centralized or it can be decentralized but insecure. It's slow, it's a lot of clicks, it's expensive. The thing is, this is obviously a need, and you can tell it's a need because users are going through all these pain points to get their tokens across, and while blockchains are having the problem of communicating with each other. This is where Axelar Network comes in. So it's not just a bridge or a hub, it's a protocol. It's an interoperability layer. It allows apps, smart contracts, developers to send general messages and data across any chains. It also supports pretty complex logic, which is something that Bridge can't do. We'll have a look at that later. So how does it do this? Well, one, it's a decentralized network of validators that run the core network to secure everything through proof of stake. In every blockchain, there are what you call secure gateway contracts. These gateway contracts, let's say between Ethereum and Avalanche and Binance, are all connected to one spoke in the wheel, if you like. This spoke is the decentralized network of validators. They confirm all the data that flows between the different blockchains. Finally, there's a bunch of really cool developer SDKs and APIs that developers can use to talk to these different blockchains without needing to write their own smart contracts, which makes life so much easier. And makes it so much quicker for developers to build apps that are more secure because they're using code that has been looked at and tested by many other developers. All of these components work together and they provide a really cool, seamless and secure cross-chain experience for users and developers. So in this case now, if you want to swap your tokens from Ethereum and Avalanche using Axelar, really easy. The API just connects both networks together and it just works seamlessly with one click. Much easier than bridging and also much cheaper. So in a nutshell, Axelar abstracts away that whole complexity of different blockchains and the heterogeneity. Every blockchain is different. It abstracts all of that and it makes it like a single uniform interface for cross-chain communication. If you make it easy for developers, they're going to create a beautiful experience for users, and that's why Axelar is great. And that's it for the first segment of our podcast. In the next segment, we're going to look at some of the features and functionalities of Axelar Network, such as the general message passing, the universal asset transfer, and the Axelar virtual machine. Stay tuned. All right. Welcome back to Podcast, the podcast that explores the latest developments and innovations in the blockchain space. I'm your host, Will, and today we're talking about Axelar Network, a project that aims to deliver secure cross-chain communications for Web3. So in the last segment, we explained the core concept and architecture of Axelar's network, how it differs from other interoperability solutions. In this segment, we're going to explore some of the features and functionalities of Axelar, such as the general message passing, the asset transfer, and the Axelar virtual machine. So, as I mentioned earlier, Axelar is not just another bridge or a hub, it's a programmable layer. It allows general messages to be passed back and forth between blockchains and also assets as well. It also supports logic to automate complex interchain tasks, such as connecting dApps and deployments. But what does that mean and how does it work? Well, let's start with the general message passing. This is one of the core features of Axelar. It allows dApps to send and receive pretty much any kind of message you want to send across any chain, calling functions across chains. What this does is it allows interactions between chains to happen for users with just a single click. A user doesn't need to access their mask and do heaps and heaps of clicks to perform a single action. It allows the user to perform, let's say, bridging tokens, or let's say it's a adapt the checks for different loan interest rates in different blockchains. This is all done with one click, as opposed to how previously with MetaMask you need to do a whole bunch of clicks, and sometimes the gas fees can also be pretty exorbitant. So with Axelar using the API, all of these messages work pretty easily. One click, it's one spoke essentially connected to a wheel that where the spoke in the middle is Axelar's API, and the edges of the wheel are all the different blockchains it connects to. And so the data is sent back and forth between these gateways. It happens really quickly, really easily. All of this is secured by Axelar's validators. So yeah, Axelar enables cross-chain function calls with a simple and uniform interface that developers can use. This allows dApps to access features and functions across chains with one click. It allows us, the users, to enjoy a more seamless and integrated experience. And one of the cool things you can do with this is universal asset transfer. This essentially makes bridges unneeded, because with Axelar you can trade tokens between blockchains really easily without needing to wrap or bridge. That makes it super easy. And again, it's just all done with an API that developers can integrate super easily. It abstracts away the whole complexity and the heterogeneity of different blockchains, different assets, and it makes everything super easy to manage from one place. And that means as a user, you can interact with any asset on any chain with one click. That also means that developers can access all that liquidity across all of those chains connected to you, the user. Now, the other really cool thing is Axelar's virtual machine. And so this is a Turing complete sort of interchain network that is run by the validators. That means that as a developer, you not only have the ability to transfer messages across chains, but then when a message is, let's call it en route, well, it's hit the Axelar network. Let's say it leaves Ethereum and it hits the Axelar network before it gets to Avalanche. While it's still in Axelar's network, you can build contracts as well that are super secure, and they're run by Axelar's validators. Those contracts can either read or relay the data or transform it in any way that you want before sending it to Avalanche. As a developer, that just gives you that much more versatility in what you can do with those messages you're sending across. So that means it's not just a telephone call or a message that is going from one blockchain to another. It means that you can do some really cool things and build all sorts of crazy applications on top of it. So that's it for this segment. In the next segment, we're going to look at the security and decentralization aspects of Axelar's network. We're going to look at the proof of stake consensus, the quadratic voting, validator security rules, and application layer safeguards. Stay tuned. Alright guys, welcome back to Blockcast, the podcast that explores the latest developments and innovations in the blockchain space. I'm your host Will, and today we're talking about Axelar Network, a project that aims to deliver secure cross-chain communications for Web3. So, in the last segment, we looked at some of the features and functionalities of Axelar, the general message passing, the universal asset transfer, and the Axelar virtual machines that allows you to create complex logic in between of blockchains. That means when you send a message from one blockchain to another, you can also do something to the message in the middle. You can transfer, relay, do whatever you want with a Turing complete smart contract ability in Axelar's network. So we've already mentioned that Axelar is a universal overlay network, and it connects all sorts of blockchains together, applications, ecosystems, and assets to give you that Web3 interoperability. But how does it do it? How does it ensure security and reliability? That's super important. And we've had cases where smart contracts have been built before, but then the security hasn't always been great. All the security has been great, but then sometimes governance hacks has happened where whales have come into a particular system and sort of hijacked it with your tokens and done what is good for them in the short term, but not great for the ecosystem in the long term. So how does Axelar secure this? Well, let's first look at its proof of stake. And so this is the mechanism that secures Axelar's core software running on the validators. So we all know that proof of stake means that validators stake their own tokens, AXL to participate in the network to earn rewards, and the more tokens they stake, the more voting power they have. The more tokens they stake, the higher the chance they have to be selected to secure the network. In exchange for that, they are rewarded with more Axelar tokens and they earn fees on top of that. When a validator misbehaves, let's say they try to override the system, once the other validators detect this, the validators has their tokens slashed, and so their stake is removed. So proof of stake is the first thing that secures Axelar's network, and it's has a couple of advantages over proof of work. The most important ones being its energy efficiency, scalability. It makes sure that all of the validators have their incentives aligned, at least for the short term, and that secures the network's transactions. However, as we just mentioned, that's not exactly enough to ensure the security and decentralization of Axelar's network. And so that's why Axelar has its quadratic voting mechanism that increases the decentralization of the network. So quadratic voting is a way of voting that balances the influence of large and small stakeholders. It works by assigning a cost to each vote that increases quadratically with the number of votes. For example, if one vote costs is 1 token, 2 votes cost 4 tokens. If you want to cast 3 votes, that'll cost you 9 tokens, and so on. And so that means that the more votes you want to cast to get a motion through, you need way more tokens than the person who's just casting a fewer number of votes. And so what it kind of does is equalizes the power between the whales, the big guys and the small guys, and it prevents the whales from dominating the voting process, and it encourages them to delegate their votes to smaller stakeholders. If I were a whale and I wanted more bang for my buck, so to speak, I would need to distribute to smaller stakeholders, because if they vote with fewer tokens, then their votes carry more weight. So quadratic voting is used by Axelar for governance decisions such as upgrading the protocol or changing parameters. It allows pretty much all stakeholders to have an almost equal voice in the direction of the network. It prevents the centralization of power from whales. And another aspect of Axelar's network security is its validator security rules. These are policies that validators have to follow to ensure the safety and integrity of the cross-chain communication network. For example, they have to rotate their keys periodically to prevent key compromise or reuse. And so these rules are secured by Axelar's core software, but then the rules are created by the governance. So all of these facets of governance come together to make Axelar more secure. So that's really cool. So as you can see, Axelar employs a whole bunch of different strategies to secure its network. Everything from proof of stake to quadratic voting and to the validator security rules. And all of these come together to ensure that the network is as decentralized as possible, and it closes as many avenues as possible, as many vectors as possible of attack. That's it for this segment of our podcast. In the final segment, we're going to look at some of the current integrations of Axelar and also its token. All right, welcome back, guys. In the previous segment, we looked at some of the security and decentralization aspects of Axelar, such as the proof of stake consensus, the quadratic voting, the validator security rules, and so on. So now we're going to look at some of the integrations of Axelar Network. Now, Axelar has been integrated to a lot of blockchains and it's growing as we speak. But right now, we're just going to look at Squid Protocol and Ethereum and why both of those are pretty important to Axelar and its token. Axelar connects a whole bunch of networks together, but who are some of these players already and how big are they? Well, let's start with Squid Protocol. And so it's one of the first dApps that have integrated Axelar Network. It's great because it showcases the whole potential for cross-chain composability. Squid Protocol is just one of the apps that is on top of that. But what we need to think about it is that it exposes the whole idea of composability between chains, but not only between chains, but between the dApps and the protocols that sit on top of the chains. So when we look at Axelar, it's still fairly young, but what we need to ask ourselves is, well, so Squid Protocol has built a really cool swap and transfer protocol on top of Axelar, which means it's on top of a whole bunch of chains. But the question we want to ask is, what apps can we expect to be built on top of Squid Protocol? And this also brings us to Ethereum. Ethereum is a massive network with heaps of dApps and heaps of liquidity just sitting there. And Ethereum is an amazing blockchain. But then it also has its problems because of its gas costs and its scaling problems, which it's dealing with over time. But until then, I think Ethereum will still have probably still has an upper limit of its scale because Ethereum does not want to reduce its security or sacrifice it to get more speed. And what that means is that Ethereum is perfect for security. It's been great for liquidity. A lot of projects have built on top of that. And now you've got all of these layer 3s and layer 2s on top of Ethereum. So the cool thing with the integration with Ethereum and Axelar is that now as many blockchains that are faster than Ethereum, better in some ways, better at least in terms of price, perhaps not as good in terms of security, can now start to connect to Ethereum and start to bridge some of this liquidity. That creates a really cool situation where, as a user, you can kind of have your cake and eat it. Where, let's say, you want to take advantage of Avalanche's speed, but then use tokens that are on Ethereum. Well, a developer can now just come and build on top of Axelar Network and connect both of these chains together and a whole bunch of other chains. So I think this is where the world is going, where the whole notion of blockchain maximalism, I think, is over. The days of Bitcoin vs Ethereum were over. The days of the Ethereum killer are gone. I think every blockchain does have its advantage, and it does have its weakness as well. And so what we're going to see in what we're going to see in the future is a lot of these blockchains still surviving because they do serve a niche. And what we're going to see is dApps building on top of these blockchains and creating a massively connected network. Now, the problem is that it's really hard for a developer to connect all of these chains together. As a developer, if you want to build an app or a dApp that connects Ethereum and Avalanche and Solana and Bitcoin and all of these chains together, it's really difficult because you'd have to essentially build your own smart contracts in every single blockchain you want to connect to. You'd have to figure out the security. You'd have to get all of those audited. And where these projects like Axelar come in is that they make this so much easier for you because you don't have to worry about the contracts anywhere. You don't have to worry about the messages or the interfaces between the different blockchains. All you have to do is just go on top of Axelar and just build your dApp there. And as soon as you've connected your dApp to Axelar's interface, well, then you're pretty much connected to all the users and all the liquidity across all of those chains. And I think that is what makes Axelar really powerful. And as the blockchain industry evolves and matures, well, inter-blockchain communication will become that more important, and it will allow new possibilities, new opportunities for decentralized technology. There's things that we can predict, for example, cross-chain smart contracts, cross-chain messaging, NFT transfers, Oracle data feeds, governance decisions that are based across different chains, and much more. And those are the only things that we can see. But then there's probably people right now just cooking up new and interesting dApps that we haven't thought of yet. dApps that, for example, look at the lending rates on different chains and match you to the best lending rate or the best place that will give you the highest interest rate. Because there's all of these inefficiencies that are stuck in different chains precisely because the chains cannot communicate as well as they should be able to. But with projects like Axelar, this this enables that communication to happen that much easier, and it allows developers to build all sorts of crazy and cool things. And so I think that's what makes Axelar's token interesting, in that it's a governance token, but then it also powers the security and functionality of Axelar. It's used for staking, voting, paying fees, accessing services, and so on. And so at the heart of it, Axelar's token represents the value proposition of Axelar's network as a universal network that connects all blockchain ecosystems, applications, assets, and users. And as that becomes more important, I personally think that the token stands to benefit from that network effect and the adoption of Axelar's network. Think Chainlink, for example. Chainlink became the de facto communication network, the de facto Oracle network for blockchains. And it first came out, some people did see this and they could see the importance of blockchains communicating with the outside world. Well, how about blockchains communicating with each other? I think that these protocols that sort of communicate, that connect different blockchains at some point will become the oracles for blockchains, but then they might also be able to connect blockchains to the outside world. So they might end up being something similar to Chainlink for blockchains and Chainlink for the outside world. And I think it's a really interesting space to watch, and I believe that inter-blockchain communication is definitely something that's going to be big in the future, because all of these chains aren't going anywhere, and we're getting more and more specialized chains, and the ecosystem just keeps growing. Well, I guess that's it for today's episode. There's heaps of projects tackling the problem of inter-blockchain communications. The ones that do succeed and become the de facto could see their token become more valued by the community. And I guess that's it for the episode. I hope you enjoyed learning about Axelar's network as much as I did. If you want to learn more about Axelar Network or get involved with this community or development, you can visit their website at axelar.network or follow them on Twitter at Axelar Network. Thank you for listening to Blogcast. Don't forget to subscribe for many more episodes like this one. And until next time, stay curious.